Good morning, students. So today we are going to study a very important topic in the chapter thermodynamics. The topic which we are about to study on today is first law of thermodynamics. First law of thermodynamics. Actually, first law of thermodynamics is the analogy of law of conservation of energy. Suppose we are giving a system the amount of heat. The heat given to a system, let me write it first, then I will explain to you. The heat given to a system is utilized in two ways. Suppose we are giving heat to a system, then it will be used in two ways. Number one is to increase the internal energy of the system, to increase the internal energy, and number two is to do the work. Now, let us try to understand that in the practical way. Suppose we have a cylinder, and in the cylinder, suppose we have kept one piston, and this piston is kept in such a way that it is a movable piston. It is free to move. Now, suppose we are giving heat to this cylinder. Suppose we have kept a gas inside the cylinder. Okay, and we are giving heat to the system. When we will give the system the heat, then what will happen? The number one thing, its internal energy will start increasing. That's obvious. Suppose we have a tea, okay, we are making out tea. Suppose we will just give it the heat, then we will find that the internal energy of the system will keep on increasing. You may notice it. The molecules of the water or the molecules of the milk or the mixture is continuously in a random motion. That means that the kinetic energy of that molecules have been increased. What is the indication of increasing kinetic energy? That is temperature. Temperature has been increased. And second thing is to do the certain work. Suppose we have kept a plate above it. We will find that after longer time, it will start moving in upward direction. Suppose it have moved by a distance dx. Fine. Now, the heat given to the system, we have given the heat, that is a form of energy. Continuously, we have given the heat to the system. That means we have given energy to the system. That have done two things. One is to raise the internal energy of the system, that is del U, plus to do certain work. If the work is done by a system, as a thermodynamics student, you have to remember this, that if the work is done by a system, we will always consider it positive. If work is done on the system, we will take it negative. Now, how the work can be done by a system? So, students, the answer is very simple. You can see when we will keep on giving it the heat, this will exert a pressure on the walls of the piston. If pressure is exerted on the walls of the piston, then we can say, now I am calculating the work. How the work is done? What is the value of this del W? Just to calculate this work done, let us assume this. So, when we will give the heat to the system, the internal energy of the gas molecules will keep on increasing and it will start exerting a pressure P on the walls of this piston. When pressure will be raised in the walls of the piston, then a force will be developed and we can easily calculate this force. Force is calculated by pressure into area. Now, suppose the pressure exerted by this gas is P and suppose the area of this piston is considered as A. So, this force is given by pressure into area. So, P into A. Now what is the work done? As we have already assumed that suppose the piston had raised it by displaced it by a distance dx. So this work done is calculated by force into displacement. Now force we already know, that is pressure into area, the displacement is dx. Now this area is in meter square, dx is in meter. When we will multiply both these, we will get meter cube. So that will be volume. So we can say this work done is equal to this delta Q is equal to P dV. So this is the external work done by the system. We have given the system an amount of heat, and because of that heat, the piston has been displaced by this certain amount. Now students, after calculating this del Q, del W is equal to PD. So this is the first law of thermodynamics. Now students, after calculating this, after considering this first law of thermodynamics, we will try to understand the second law of thermodynamics. Actually, there are few kind of processes where we can apply these laws which we have studied. So there is one process known as isothermal process. Isothermal process. An isothermal process is always considered to be a slow process. Isothermal process, slow process. By the name itself, it is very clear. Isothermal means no change. Iso, no change. Thermal, temperature. No change in temperature. If a process is held out in such a way that there is no change in temperature, we call it an isothermal process. Now, how is it possible for a process to be an isothermal process? Suppose we have a cylinder and a gas molecule is kept inside the cylinder, and suppose we are giving certain amount of heat to this cylinder, this gas. Now, because of this gas, the internal energy of the system will increase and it will start doing certain work. Certain work means the piston will be moved by a certain distance. Right? Now, when this piston will move by a certain distance, when this piston is supposed to move by a certain distance, it means there is expansion in the gas. It means the internal energy will decrease. Because whenever there is an expansion, work is done by the system. And when work is done by the system, internal energy will decrease. How this will help out? How first law of thermodynamics can be applied to this case? Isothermal. Del Q is equal to del Q plus del W. Del Q is equal to, here we are already seeing this is an isothermal process. Means there is no change in temperature. How this is possible that there will not be any change in temperature even when we are giving the heat to the system? We are giving a certain amount of heat to the system, then obviously the temperature will change? No, not at all. Because we are using a wall which is a diathermal wall. The wall which we have used is diathermal wall. It is also known as conducting wall. Heat is given to the system, temperature will rise, but at the same time that the temperature which is rising is given to the surrounding. It is not, the system is not holding the temperature. The heat is given in such a rate that it is not increasing the internal energy of the system. Even all the energy is used to do a certain work. Because del U will be equal to 0. There is no change in temperature. It means there is no change in energy. It means del U will be equal to 0. So here we can say del U will be equal to 0. Here we can say del Q is equal to del U. So when we will apply first law of thermodynamics in an isothermal process, then all heat given to the system is converted in the form of work. Means we are giving that much amount of energy to a system that all the energy is used in the form of work. No part of the energy is used to increase the internal energy of a system. Fine. So this is isothermal process. It is a slow process because you have to ensure if this will be a sudden process, then whole the temperature which will be raised by this gas will not be able to transfer in the surrounding. So we have to ensure that the rate of giving out the temperature and the rate of consuming the temperature in the surrounding should be equal. So it is going to be a slow process. Now, a second kind of process which we have to study in thermodynamics is adiabatic process. What is an adiabatic process? In an adiabatic process, the rate of change of heat is equal to 0. There is no change in the heat of the system. What is the meaning of this? If we will apply first law of thermodynamics in an adiabatic process, then del Q is given by del U plus del W. Now, if del Q will be equal to 0, del Q will be equal to 0, 0 is equal to del U plus del W. Means del U will be equal to either minus del W, or we can say minus del U will be equal to plus del W. This will be the condition. Now, what is the practical meaning of this? Del U is equal to minus del W. Suppose you are not giving heat to a system. Suppose you are not giving food to a human being, and you are applying a certain work from it. You are insisting that person to do a certain work. You are not giving energy. Del Q is equal to 0. No energy is given to the body. But still you want that person to do a certain work. What will be the case? That will be the case that as soon as if the work done will be positive, the internal energy of the body will keep on decreasing. You haven't given, a person haven't eaten anything, and you are asking him, because del Q is 0, no heat is given to the system. No heat is given to the system, and you are asking to do a certain work. Then it's internal energy. How he will do the work? He will do this work by himself. So if he will move the piston upward, the internal energy of the system will decrease for sure. So this is the physical indication of the first law of thermodynamics applied to an adiabatic process. Now, let us come to evaluate this. Del U is equal to minus del W. What is the meaning of this statement? Suppose let us assume an adiabatic ball in a cylinder, and suppose what is the meaning of minus del W? Means work is done on the system. Means we are doing work on the system. On the system means we are compressing out. We are compressing this piston badly. And when we will compress this piston badly, its internal energy will increase. Minus del W, work is done on the system, but because del Q is equal to 0, so the meaning of this statement is minus del W will be equal to del U. All the work done will increase the internal energy. That's why internal energy is positive and del W is negative. So this is the first law of thermodynamics when it is applied to an adiabatic process. Now students, after this we have to study isothermal process. Isothermal process. What is an isothermal process? An isothermal process is a one in which the volume do not change. Isothermal process. There is one process isobaric. Bar is the unit of that pressure. Fine. So in that isobaric process, pressure do not change. Isobaric process, volume do not change. Now, if we come to know about the first law of thermodynamics, del Q is equal to del U plus del W. The meaning of this statement is del Q is equal to del U plus P del P. Now, if there is no change in the volume, that means del P will be equal to 0. So del Q is equal to del U. All heat given to the system will use to increase the internal energy of the system. That is isothermal process, first law of thermodynamics. So students, I hope you understood the today's topic in well manner. Thank you. God bless you. Have a very nice day.